Hello students, how are you all? I hope everyone fine. So in last class we learned different types of sets, okay? So today we are going to continue, okay, different types of sets and relative problems, okay? So in last class we learned two intervals as a types of sets, closed interval and open interval. So it comes under the same heading, types of sets, and today we are going to learn two more intervals, okay, of real numbers. Okay, in which the first one, okay, today's first topic, the set of all real number, the set of all real number x such that x is between a and b, including a but not including b, including a and not including b, is denoted by this type. Observe carefully, close bracket always represent that you are going to include that extreme, open bracket always represent that you are going to exclude the extreme value, okay? See, observe carefully here, less than or equal, so close bracket. Here only less than, so it is open bracket. Observe carefully. And this type of interval is known as half close. One side matra close, in one side close agila. Half close. Okay, so whenever the set is like this, then you are going to represent this as an interval. Okay, see, for example, if you write like this, then how to actually, what is the meaning of this in real line? Real line and x-axis. Observe carefully. So it is 0, it is 2, suppose if you have 5 here. So what is the meaning of 2 to 5? Don't think that it is 2, 3, 4. No, it is not just 2, 3, 4. 2, 3, 4 are the members of the elements, but not only that is a member of the elements. It is all real number from 2, starting from 2 up to 5, not including 5. This represent the half open. Right? 2 is included but not 5. 2 is included but not 5. Artha agtide helodu? So in real number this can be represented like this. In real number this can be represented like this. How to write this in terms of set builder form? X such that x, okay, is between 2 and 5, including 2, not including 5. Including 5, not including 5, one and the same. This is an example of, half close. Half close starting with the close but ended with the open bracket. Okay, so this is one more type of interval, half close. Okay, adhe tara innond pattern ide nodi, the set of all real number x such that, set of all real number x such that x is between a and b again, but excluding a, because here equal symbol is not there, including b, equal symbol is included. Okay, so excluding a, including b, correct? And it is denoted by like this. Exclude anta bandaga open bracket, include bandaga square bracket, and it is known as, see, half open. Actually, open in the start but ended with the close. Okay, and it is known as, okay, half open. For example, suppose it is like this, minus 5 to 1, minus 5 to 1. Then how to represent this in a real line? Here 0, here minus 5, here 1. It is represent starting from 5 but not including 5 and ended with 1, including 1. So this is the answer. This region, each and every real number between these two numbers will be included in the set. How many elements are there in this set? Infinitely many elements are in this set. These are the examples of infinite set. All the 4 different types of intervals are the examples of infinitely many number of sets or infinite set. So here set this is called half open, this is, okay, half close and half open. Just remember like this. Okay, whenever you include open square bracket, whenever you exclude open bracket. So these are the 4 different types of intervals under the heading of types of sets. Okay, so next one more type of set we have, and it is known as power set. It is known as the power set of the set. It is known as power set of the set. Observe carefully. The collection of all subsets of a set. Collection of all subsets of a set is known as the power set. The collection of all subsets of the set is known as power set of A, and it is denoted by, P of A. It is denoted by P of A. Okay, P of A represent the power set of the set. What do you mean by power set of the set? Set of all subsets. Set of all subset of the set is known as the power set. Okay, for example, if A is equal to A comma B comma C, okay, then can you tell me what is the power set? How to write the power set? Remember, it's a collection of subsets, and the collection and set of all, so it should be between the flower bracket. So all the subset you should write. First is null set, the singletons, alva. Correct? Next, the two element set A comma B, B comma C, and C comma A, and the last one the set itself. Okay, so this is an example of the power set, and then set of all subsets of the given set is known as the power set. Set of all subset, remember, set of all subsets of a set, okay, is known as P of A. Set of all subsets of the set is known as the power set of the set. Okay, so in last class I gave some note, and okay, using that particular note I can give you one more, and it is also important. If the number of elements in a set A is n, if number of elements in a set A is n, then number of elements in P of A, and then the number of subsets of the given set. What is the number of subset of the given set? 2 raised to n, and P okay, 2 raised to n. So number of elements in the power set, number of elements in the P of A is 2 raised to n, okay. CET gela bekagata 1 mark board exam allu barabodu, okay, remember that. Yeah, so last type of the sets is the universal set. Universal set, again the term itself explain everything. So I'll define, observe carefully. The set of all, it is again a set, it is again a set. Universal set must be a set of all elements of all sets. E word important. It is a set of all elements of all the set. Set of all elements of all set is known as universal set. For example, if A is equal to 1 comma 2 and B is equal to 3 comma 4, C is equal to 5 comma 6, then if you want to write the universal set for this set, okay, here I can write one more information. It is denoted by, it is denoted by U, capital U like this. In it is denoted by capital U, okay. Now universal set of this must be at least containing these elements. Nothing to worry, but these elements should be there. The universal set may contain other than the elements of the sets, but the elements of the given set must present in the universal set, okay. All the elements of the given set must present in the universal set. It may contain more than that also, don't worry. So this is known as the universal set for these three elements. If I take one more example, like set of all natural numbers, set of all integers, set of all rational number, okay, set of all, okay, set for this three set, what is the universal set? What will be the universal set of integers, set of all natural numbers, set of all rational numbers, set of all irrational number? R contain each and everything, N, Z, Q, I, everything contain in R, and R contain other than these elements also. So universal set of this set is R. Suppose if I include here R, then universal set will be the complex numbers. The universal set is a set of containing all elements of all set containing all the elements of all set. So we learned so many different types of sets. I'll just recall once, then we are going to solve problem from exercise. So starting from the null set, then set containing no elements, then singleton set containing single element, then finite set with the finite number of elements, infinite set with the infinite number of elements, okay. Then we learned subset. Okay, if an element set is called subset of another set if every element of A is present in B. Proper subset, right? Say all the subset excluding the set itself. Superset, right? Then after that we learn the different types of intervals as a subsets: open interval, closed interval, half open, half closed. Then we learn the power set and the universal set. So next problems from exercise based on these types of sets and its definition. Okay, so few problems we are going to complete now, okay, in this class. So remember all the definition and the theory part, okay, related to these different types of sets. Okay, so the first problem under this heading is set A is equal to 1, 2, 3, 4, 5. Okay, here observe carefully. This will be considered as an element of the set, okay, because it's set inside another set. which of the following statement is incorrect and why? Which of the following statement is incorrect and justify your answer. Okay, the first one, set 3 comma 4 is a subset of A. Is it true? Is it true? Definitely no. This is an element. Okay, this 3 comma 4 will be considered as an element of the set. This 3 comma 4 will be considered as an element of the set. So answer is not true, false. The statement is false. The reason is, okay, the right answer is 3 comma 4 is the member of A, not the subset of A. It cannot be called as a subset. It is a member because it is a member of the element, not the subset of the set. So right answer is this, so this answer is wrong. What about next one? Is it true? Yes, it is true. Because if I consider 3 comma 4 as an element, then if you write the element between the two braces, it will be considered as a subset. So this is true, okay, because 3 comma 4 will be considered as an element. So okay, with the two lower bracket with an element, it is a subset, not belongs to the element. Okay, so ಇಲ್ಲಿ true ಅದರ reason ಬರಿಬೇಕಂತಿಲ್ಲ, incorrect ಅದರ ಮಾತ್ರ reason ಬರೆಯೋದು. Next, 1 belongs to A. 1 belongs to A. Yes, it is true because 1 is a member of the set, not the subset of the set. 1 is a member of the set. It is true. Next, 1 to 5 is a subset of A. Is it true? Again, it is true because it is the subset, not the element. It is a subset, not the element. Is this true? Yes, again this is true because it represents collection of subset and it is a subset of the set. Alva, 5 is a subset, right? Yeah, it's a subset of the set. Yeah, true, no? So pi is also one of the subset, so you can represent like this, nothing to worry. But this is false. 5 must the subset of A. 5 must be the, okay, sorry, this is actually fifth question is false, sorry. Okay, fifth question is false because the reason is, the right answer is, this is a collection of subset. It's a proper subset of the power set, not the set. This is false, not true. Okay, this is the member of the power set, not the member of the set. Member of the set is not there like this, right? So it is not a subset. This is wrong because this is a subset of A. So this is the right answer for this. Okay, ಇಲ್ಲಿ bracket ಇಲ್ಲ ಅಂತ ಆಗಿದೆ, okay, fine. But with the bracket, it is a member of the power set. It is the member of the power set, so it cannot be the member of the, okay, or it cannot be the subset of the set. It is a subset of the power set. So this is false. So right answer is here. This is again false because right answer is the subset. Not belongs to, right answer is the subset. One subset of A, false because 1 is a member of A. It is false. The right answer is 1 belongs to A, not 1 is a subset of A. ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳೋದು? So the first 7 answers are here. ಅರ್ಥ ಆಯ್ತಾ? So you have to identify the incorrect answer. You have to check whether the given statement is incorrect or not. If it is incorrect, write the reason. If it is correct, no need to write the reason. 1 mark ಕೇಳಬಹುದು. ಎಲ್ಲ 7 questions ಕೇಳಲ್ಲ, 1 or 2 questions ಕೇಳುವಂತದ್ದು. So write, okay, properly. Next one. Write down all the subsets of the following sets. Write down all the subsets of the following set. Yeah, about this I told when I wrote the examples of subset. I'll take one problem in exercise with the 4 element and I'll show you how to write the subset of 4 element set. Subset ನೆನಪಿದೆ ಅಲ್ವಾ? So we are going to write the subsets now. Tell me how to write. Which is the first set you can, which is the smallest subset? Null set. Okay? Then write all the single element. 1, 2, alva, 3, 4. First tell me how many elements you should get. How many elements you should get? 2 power 4. 2 power 4 ಅಂದ್ರೇನು? 16 elements ಬರಬೇಕೀಗ. So already ಎಷ್ಟಾಯಿತು? 5 elements ಆಗಿದೆ. Next 2 element set. 1, 2 ಅಲ್ವಾ? 1, 3, 1, 4. Then 1 ಇಂದೆಲ್ಲ ಆಯ್ತು ಅಲ್ವಾ? Next 2, 1 ಬೇಡ. 2, 3, right? 2, 4. Next, okay, 3 in the start. 2, 1 is there. 2, 2. 2, you cannot write. 2, 3. 2, 4 is over. Next 3, 4. 3, 2 ಬೇಡ, ಇಲ್ಲ ಆಲ್ರೆಡಿ ಆಗಿದೆ ಅಲ್ವಾ? 3, 1 ಆಲ್ರೆಡಿ ಆಗಿದೆ. So okay, these are the 2 element set. ಅರ್ಥ ಆಯ್ತಾ? 1, 2, 1, 3, 1, 4. 2, 3, 2, 4. 3, 4. ಕರೆಕ್ಟಾ? Next 3 elements. 1, 2, 3. First count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You know, okay, 4 elements. 1, 2, 3. Next 1, 3, 4. Correct? Then 2, 3, 4. right? Any other possibilities? No. So one more I think possible. 2 3 4 is okay. Then 3 4 1. 3 4 1 agida illa. 3 4 1. 3 4 1. No, any other possibilities? 1 2 3 1 3 4, everything is done. 1 4 2, yeah, it is there. 1 4 2, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, okay, done. So last one is the set itself. So remember, so number of subsets is 16. So we got 16 in the list. Clear? So this answer to first question is 16 elements. These are the 16 elements of this, okay, subsets of the given set. So the second question is like, this is answer to first question. What is second question? Subset of null set. How many subsets you can have for the null set? So subsets of null set is again null set. Only one set is possible, that is a null set itself. No other subsets are possible, only the null set. So here you got 16, here you got only 1. So you can try like that by taking some example, like 3 elements are already practiced. 5 elements bekandila 2 power 5 32, it's not easy. 2 elements I think I gave an examples. 1 element is a singleton itself, so no other answers. Okay, let me take one more example. Set with singleton. What are the how many subsets? Null set and the singleton, 2 subsets, null set as well as singleton. Either subsets nenpeli confusion agbidi. Okay, subset is first is null set, then 0 element, then singleton. So up to 4 you learn, everything is done. 5 element set is not required. Yes. Okay, next question. Write the following as interval. So x such that x belongs to R. X is between minus 4 to 6. BLR 6. ಹೇಗೆ represent ಮಾಡ್ತೀರಿ? See here, minus 4 is not included because equal sign is not there ಅಲ್ವಾ? 6 is included, so square bracket. 1 mark question ಅಷ್ಟೇ. ಅರ್ಥ ಆಯ್ತಾ? ಯಾಕೆ ಓಪನ್ ಬ್ರಾಕೆಟ್? it not included, equal sign is not there. Here why it is included? Because equal sign is there. Similarly next one, ಏನು ಹೇಳ್ತೀರಾ ಆನ್ಸರು? minus 12 to minus 10. No, both are not included, so it's open interval alva. Minus 12 to minus 10. One thing you remember, the first element always less than the second element. First element must be always less than the second element. Remember that. Okay, by mistake also don't change the position. Here which is included? First element is included, last element is not included, so it's 0 is included, 7 is not included. So like this the problem part will continue. So next question, write the following intervals in a set builder form. So in last part you learned writing the intervals, writing the set builder form into intervals. Now it's a reverse process. Set builder form now barebe intervals will kotiyare. So how to write this? So this is a set of all x such that x is between minus 3 and 0, and observe bracket properly. Both bracket shows that extremes are not included, so it is less than x, less than 0. Both are not included. Remember, always the first element is less than the second element, so take care of that. Now this is 6 between 6 and 12, and including 6 and 12 because both are square bracket. So it's a set of all x such that it is between 6, okay, including 6, less than 12 as well as including 12. So set builder form, correct? So let's write this one, x such that 6 is not included and 12 is included, correct? Idala 1 mark question. I hope you will understand easily. X such that minus 23 is included, 5 is not included. Got it? Very good. So first 4 problems artha aitalva. Writing the intervals in set builder form. Last type idreno intervals, set builder form in the intervals, interval in the set builder form. Remember both are important for 1 mark. Okay, one single question, okay, 1 mark question usually keltare exam alli. How many elements has p of a if a is equal to null set? If a is equal to null set, you have to get the number of elements, okay, of p of a. What is p of a? The power set. What is the power set? Set of all subset of the set is known as the power set, alva? So S subset ide, so p of a is nothing but number of subsets. We first you have to find out number of subsets of null set. What is number of subset of null set? Is 1, alva? Is 1. 1 and only one. What is that? The null set itself. So number of elements in the P of A is also 1. So number of elements in P of A is 1 because for the null set is only one set is subset which is null set itself, no other elements. So I left some problems in this exercise which are very simple. I'll send that picture to your in a group and you have to work out and you have to send it to me. So remaining problem of this exercise will be homework problem because tumma simple ide. So difficult part and the important part I took. The remaining simple part you are going to solve. Okay. When you see this video, you will on that day only you will get the picture of that as a homework work. Okay. Yeah. So I'm moving to the one more concept in set theory. See, in the beginning we learned two types of representation of the set, roster form and set builder form, tabular form and set builder form. So one more way we can represent a sets, we can represent a set that is in terms of diagram, and that representation is known as Venn diagram. Venn is a mathematician, so use capital letter, not WHEN, VENN, Venn diagram. So the person who introduced this concept is nothing but a Venn. He's a mathematician, so it is known as Venn diagram. In this diagram or in this method, we are going to represent set as a diagrams, not using braces or the elements. We are going to write the elements but not between the two braces inside some diagram. Okay, so remember this is an important topic, listen carefully. In this method we represent sets in terms of diagram. Please remember that. Okay, in name itself explain Venn diagram and representing set in terms of diagram. Okay, in this diagram we are going to represent set as closed curve. Any closed curve is allowed. Definitely any closed curve allowed, but in particular we use circle to represent a set. In particular we are going to use circle to represent a set. Okay, and its elements by dots. Dots is a point like this, and its elements by dots. Suppose you are representing the universal set in this set. Okay, in this diagram you are going to represent in terms of rectangle box. This we are going to use, so I gave the information. Remember, set will be represented in terms of circle, closed curve will be represented as a circle here, but actually any closed curve is allowed. Sometimes we use ellipse also, like this also we use, but usually or most of the time we are using the circle only to represent a set, so we will consider here closed curve is circle only. Okay, and elements by the dots, and the universal set by the rectangle box. A square box is also allowed, don't worry, because square is also a rectangle. So square box or rectangle box, but that should be a closed box. So let me explain this concept with an example. Observe carefully. So I'll take one three set or one example. Observe carefully. A is equal to 1 2 3, B is equal to 2 3 4, C is equal to 3 4 5. And I'll consider the universal set is 1 2 3 4 5. You can take more than 5 elements, 6 7 also you can take, but if you take some other elements, okay, let me take, you'll get some information here. Let me take 2 more elements which are not in the set ABC, but it is that in the universal set, and this still a universal set for the set because all the elements of ABC are present in U. Did you agree with me? Now I'll show you how to represent in Venn diagram. This is called Venn diagram. This is known as Venn diagram. First universal set again ಬರಿಬೇಕು, square box or rectangle box. ನೀವು ನೀಟಾಗಿ ಬರೀರಿ, ಪೆನ್ಸಿಲ್ ಸ್ಕೇಲ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡೆ ಬರೀರಿ. Okay, ನೆನಪಿರಿ, perfect square box ಬರಬೇಕು. Circle, ಎಷ್ಟು circle ಇದೆ? 3 circle. Now I wrote like this because the all are not disjoint. Disjoint ಅಂದ್ರೆ you will come to know there is a common element ಅಲ್ವಾ. So I'll write the 3 set like this. Observe carefully. First set ಅಲ್ಲಿ ಏನಿರಬೇಕು? 1 2 3. I wrote 1 here and 2 3 here. Why? 2, 3 is also present in B and 3 is present in C, alva. So 3 idu C, alva. This is A. Observe carefully. This is A, alva. This is B, correct? And this is C. So 3 is included in C, right? 3 is included in C, so I wrote here. 2 is not included in B as well as in A, but not in C, so I wrote here. Artha agtide heludo? Then 1 is only included in A, so I wrote here. ಅರ್ಥ ಆಯ್ತಾ? ಹೀಗೆ ಬರೋದು ಯಾಕಂತ ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಬಿ ಅಲ್ಲಿ ಸಿ there is no elements like only present in B. 2 is present in A, 3 is present in C, 4 is present in B, 4 is present in C, alva. So B ಅಲ್ಲಿ there is no element which is only present in B, so everything will come as like this. But I didn't write 4 here because 4 is not, okay, 4 is present in C but not in A. ಇಲ್ಲಿ 4 ಬರೆದ್ರೆ ಏನಾಗುತ್ತೆ? 4 is present in A also, but 4 is not there in A. ಅರ್ಥ ಆಯ್ತಾ? So only 4 is present in B and C, so I wrote here. But there is one element in C which is present only in C, so that is 5, so that I wrote here. So this is a representation of this set, okay, in terms of diagram, and this is known as Venn diagram. ಅರ್ಥಾಯ್ತಾ? So next we are going to solve some problems based on this Venn diagram. We are going to learn different operations on sets like union, intersection, complement, difference, so many things we are going to learn, and we are going to learn those operations on sets using Venn diagram also. So this topic is very important. So remaining part, okay, I will continue next class. Thank you.